my dear students, in previous lecture we have completed nomenclature of aldehyde and ketone. Now in today's lecture we will discuss physical property of aldehyde and ketone. Now particularly three type of physical property we have to discuss. First, state and order of aldehyde and ketone. Second, molecular masses of aldehyde and ketone and its boiling point, and comparison of this boiling point with this alcohol, ether, hydrocarbon compound, and third, solubility in a water. So first, when we take this aldehyde as well as ketone, then it is observed that lower molecular mass containing aldehyde as well as ketone are present in a liquid state. Suppose when we take this formaldehyde, then formaldehyde will be present in a gaseous form and it can be dissolved easily in water, and its solution in water is known as a formalin. So aqueous solution of formaldehyde is known as a formalin, and we know that it has a pungent smell. When we take this formaldehyde, then it has a pungent smell, uncomfortable little. It has antiseptic property. So आपने देखा होगा in biology, to preserve different species, then formalin solution will be used. Similarly, to preserve dead body also formalin solution will be used, and formaldehyde is also used in polymer to make a different type of resin. You know very well, phenol formaldehyde, resin bakelite, with melamine also it gives a melamine polymer. So formaldehyde can be used for variety of purpose. Then after another aldehyde, suppose we take a acetaldehyde, then its physical state will be a liquid. So as the number of carbon atom increase, it will start to convert in a gas to liquid state, and higher molecular mass containing aldehyde as well as ketone will be present in a solid state. But lower molecular mass containing aldehyde, up to 6 to 7 carbon, then these are the present in a liquid state. So when we take this structure is of ethanol. Ethanol will be present in a liquid state. Similarly, when we take benzaldehyde, aromatic aldehyde, then it will be also present in a liquid form, benzaldehyde. Then after acetone, 3 carbon containing first member of ketone, then acetone having a pleasant smell. When we take this 3 carbon containing ketone, then it is acetone. It has a pleasant smell and useful in a paint industry. It is useful as a solvent also. So lower molecular mass means first member of aldehyde will be present in a gaseous state. Similarly, other aldehyde and lower mass containing ketone will be in a liquid state. As mass increase, they convert to in a solid state. They having a fragrant smell if aldehyde having a higher molecular mass, but if lower molecular mass, then it is a pungent smell. Then after comparison of this boiling point with alcohol as well as carboxylic acid, then it is observed that when we take this aldehyde, then aldehyde boiling point will be less as compared to carboxylic acid. When we take, then carboxylic acid having a higher boiling point as compared to alcohol. Then comparison with this alcohol having a higher than ketone, and ketone having a higher boiling point as compared to aldehyde, and aldehyde having a higher boiling point as compared to ether, and last ether having a higher as compared to hydrocarbon. So questions should arise in your mind. Questions should arise in your mind. Why boiling point of ketone and aldehyde is less as compared to carboxylic acid? Then when we take this carboxylic acid, then in structure of carboxylic acid, it has a tendency to form a hydrogen bond. 2 molecules of carboxylic acid having a tendency to form a hydrogen bond. So there will be an intermolecular hydrogen bond will be there. Oxygen having a partially negative charge, hydrogen having a partially positive charge, so it has a bonding. Similarly, in alcohol molecule also hydrogen bond will form. This bond is nothing but hydrogen bond. So in carboxylic acid, strong hydrogen bond as compared to alcohol. When we take the molecule of alcohol, then it has also hydrogen bonding. We know very well. Yeah, आप जानते हो, in alcohol chapter you have studied. So in alcohol also there will be presence of hydrogen bond. But when we take a aldehyde or ketone molecule, then in aldehyde or ketone there is a no possibility of formation of hydrogen bond. So in case of aldehyde, there is a no possibility of formation of hydrogen bond. So there will be only weak dipole interaction will be there. Carbonyl carbon हैंगे partially positive charge, oxygen हैंगे partially negative charge. So in a case of aldehyde or ketone, there will be a weak dipole interaction will be there. Suppose I have taken a ketone molecule, then there is also presence of weak dipole interaction. Here carbonyl carbon, so carbon हैंगे partial positive charge, oxygen हैंगे partially negative charge. So in case of ketone, there will be always dipole interaction. So dipole interaction is comparatively weak as compared to hydrogen bond. So आपको समझ में आ गया that boiling point of aldehyde and ketone will be less as compared to alcohol and carboxylic acid. In carboxylic acid, there will be a strong intermolecular attraction as well as hydrogen bonding. So carboxylic acid is the highest, then after alcohol. Now in case of ketone and aldehyde, dipole interaction is weak. So carboxylic acid as compared to carboxylic acid, their boiling point will be less. Now further, in isomeric ketone and aldehyde, in a case of isomeric ketone having a higher boiling point as compared to aldehyde. Reason is, in a case of ketone, there will be a two donor group. In a case of ketone, there will be a two donor group. So the dipole interaction will be strong in a case of ketone as compared to aldehyde. So ketone in a case of isomeric aldehyde as well as ketone. In a case of isomeric aldehyde as well as ketone, boiling point of ketone will be higher as compared to aldehyde. अब इसकी comparable molecular mass, तो comparable molecular mass किसको कहते हैं? Suppose I have taken a 4 carbon containing butane. Then in 4 carbon containing butane, you are knowing very well structural formula: carbon 4, hydrogen 10. Now calculate what will be molecular mass. 1 carbon 12, 4 carbon 48 plus 10 for hydrogen, so it will be a 58. Now this 58 we compare with the aldehyde. Then suppose I have taken this aldehyde CH3, CH2, CHO. This is nothing but propanol. So when we take this propanol, it has a number of carbon atom 3, hydrogen atom 6 and oxygen 1. Now molecular mass we can take that for 1 carbon 12, so 3 carbon 36 plus 6 plus oxygen 16. So sum of this 6 plus 6 plus 6, 8. Now 3 plus 1, 4 plus 1, 5. So it has also 58. So now you can check that aldehyde as well as hydrocarbon having a almost equal molecular mass. So it is considered as a comparable molecular mass. So in case of comparable molecular mass, in a hydrocarbon there is a no interaction, no dipole interaction, no hydrogen bonding. So hydrocarbon having a lowest boiling point. So you observe that hydrocarbon having a lowest boiling point. But ether, as compared to ether, or we can say name of this structure will be methoxyethane. Boiling point will be less as compared to aldehyde. So now here comparison is given. When we take this normal butane, in normal butane, molecular weight 58 and boiling point is 273 Kelvin. Now in case of methoxyethane, boiling point is 281 Kelvin and molar mass we have calculated is almost 60. Almost 60. Now in a propanol, molecular weight is 58 and boiling point is 322. So in hydrocarbon there is a no hydrogen bonding, no dipole-dipole interaction, so lowest boiling point. In ether, weak dipole-dipole interaction, so boiling point is comparatively high as compared to hydrocarbon. In aldehyde, interaction is highest, dipole-dipole interaction is high, so it has a higher boiling point as compared to this. And in case of ketone, suppose we have taken 3 carbon containing acetone, then it has a 2 donor site. 2 alkyl group are donating electron pair, so it has a 329 Kelvin. Then alcohol, propanol, having a 370 Kelvin, and ethanoic acid 391 Kelvin. So here propanol and ethanoic acid having a hydrogen bonding. So we can say that in a aldehyde and ketone, when compared, then it is a less boiling point as compared to carboxylic acid and alcohol, but higher boiling point as compared to ether and hydrocarbon. In a case of isomeric aldehyde and ketone, boiling point of ketone is higher as compared to aldehyde. So पहले इसका स्क्रीनशॉट ले लीजिए. Then we discuss third property of aldehyde and ketone. Now solubility of aldehyde and ketone. Lower mass or lower molecular weight containing aldehyde, suppose formaldehyde, then after acetaldehyde, then acetone, these all are water soluble. Then question should arise in your mind, why they are water soluble. Reason is that they form hydrogen bond with water molecule. So aldehyde and ketone in their aqueous solution form hydrogen bond with a water molecule, and because of this lower molecular mass containing aldehyde like a formaldehyde very easily soluble in a water, and just we have discussed that its aqueous solution is known as a formalin. Similarly, aldehyde also, acetaldehyde also soluble in water, acetone is very easily soluble in a water. But the number of carbon atom increase, their solubility in water will decrease. So, question should arise in your mind, why aldehyde and ketone is soluble in water? Then it is observed that it has a tendency to form hydrogen bond. So, here मैंने aldehyde का structure लिया. Now in structure of aldehyde, oxygen लेंगे partially negative charge, carbon लेंगे partially positive charge. Now in a water molecule, hydrogen लेंगे partially positive charge. So negatively charged oxygen of carbonyl group form a bond with a hydrogen of water molecule. So due to this, it is observed that aldehyde and ketone form hydrogen bond. So same thing in a case of aldehyde as well as we can write in case of ketone. In ketone there will be a 2 electron donor group will be there. Carbon हैंगे partially positive charge and oxygen हैंगे partially negative charge. Just I have discussed that water when we take, then water having a positively charged hydrogen atom. This positively charged hydrogen and electronegative atom of oxygen having a hydrogen bond. So in ketone also hydrogen bond will form. So aldehyde as well as ketone form hydrogen bond with a water molecule, and because of this aldehyde as well as ketone are water soluble. But we have to write that lower molecular mass containing. If lower molecular weight, then they are very easily water soluble. Then one more thing, as number of carbon atom increase, then common thing, it create a hindrance in a hydrogen bond, and create hindrance in hydrogen bond, therefore solubility in water will decrease. So it is observed that solubility in water is going to decrease. So aldehyde as well as ketone are water soluble, but number of carbon atom increase, their solubility will decrease. So aromatic aldehyde are less soluble in a water as compared to aliphatic lower molecular mass containing aldehyde. So my dear students, in today's lecture we have discussed physical property of aldehyde and ketone. If you like this lecture, then don't forget to like, share and subscribe.